Okay, welcome to Doozer Shop. This video is going to be about my rotary phase converter upgrade. Let me show you how it's all hooked up, and if you guys got rotary phase converters or thinking about hooking up a rotary phase converter, this might be helpful. So let's go handheld and show you all about it. Alright guys, when you come into my shop, you have the circuit panel. I got the cover off the circuit panel, as you might recognize. But the first thing that we see is the light switches, of course. And this is kind of a new addition, these two push buttons. You may remember the push buttons to start the three-phase power. I had that push button right mounted on the side of the breaker panel, and seeing as I upgraded the phase converter to two-phase converters, I've got the double buttons now, the secondary set of buttons. So I had to come up with an electrical box. I was going to get a 4-inch gang box and just put these push buttons side by side. And then I just kind of happened to find this box. This thing's pretty cool. It sticks off the wall about the same distance as the fuse panel, which is fine. And I had to plug a hole in it, but that's okay with the knockout. But so that's that. That's how you start the rotary phase converter. And I'll kind of show you what the deal is. I left the screws loose on purpose so I can show you guys. Alright. So basically, you have a start switch, a stop switch, and the center is the a light that illuminates when it's running. So let me kind of. So this black cable. Just so you know, I switched off the breaker, so you guys don't worry, I'm not going to shock myself. I turned the breakers off for this. This is called irrigation wire. I guess it's for sprinkler systems or something, but it's a 18 gauge solid wire, and it's 5 wires in each sheath. You can get, I think, 5, 7, and 10 wires. But it just worked out that each push button needed 5 wires. I guess 2 for start, 2 for stop, and 1 for the light. But anyways, so that's how that works. I just thought I'd give you guys a quick, like, okay, that's inside the push button box, and it worked out really well. This is just a, signal. Let me put this screw back in, and I'll show you how it works. Alright guys, got you back, put the screws in. So let me show you how this works. I got the breaker flip back on. So basically, this is one rotary converter, okay? And this is the other one. So now I have both converters running. So this is 6 horsepower worth of converter, and this is another 6 horsepower. So I have 12 horsepower worth of rotary phase converter. So that can easily start a 10 horse motor, and that's kind of why I did this. But there's something special about this. You can see the lamp goes off. You can start either. You can run one alone, you can run the other one alone, or you can run them both. But the deal is, whichever one you start first disables the starting circuit for the second one, and all it does is it brings the contactor into the line. So if I start this one first, this second one's running, and now it disables the starting capacitors in the first one. because it doesn't need it. Once you have three-phase being generated, a second motor will pick right up. A third motor, a fourth motor, doesn't matter. So you only need the start capacitors to start the rotary phase converter. And any other additional capacity, whether it be, you know, basically I'm bringing in basically another three-phase motor. And there it is. If I did not disable the start capacitors, I tried it. It does work. It kicks the motor really hard though. The rotary phase converter generator motor, whatever you want to call it, it kicks it really hard if you don't disable the start capacitors when the first one's running, okay? And I don't know, but I think if you kept doing that, it's like you'd create a surge that might blow out the capacitors. And you can blow out these capacitors, okay? So basically, whatever one you start first, it disables the starting circuit on the other one and just brings it in line, because it'll start, basically, whatever one you're starting is making three-phase. Like three-phase, okay, use the capacitors to start it. Now three-phase is flowing, and it doesn't need the phase shift of the capacitors to start the second one. So now that started with just the three-phase being generated from the first one. So you can start either one first. Doesn't matter. You can see the lights go dim in the middle. So that's really cool. I'll show you how I rigged a circuit up on the upstairs panel. So basically, this is a control circuit, and it comes in here and you can't see it, but there's that irrigation wire. So it feeds up into that's one, and I believe that's another. So how this whole deal works is this whole panel is just single phase 230 volts. Okay, single phase 230. This is a little different how I wired this. Okay, and I'll show you why. So AC is air conditioning. I'm going to put in another double breaker for air compressor. But anyways, so RPC, this is rotary phase converter 1, single phase, 220, 230, whatever you call it, feeding it. And then I put these breakers directly opposing that. So this is the second rotary phase converter. So rotary phase converter number one, rotary phase converter number two. So it's kind of neat. So what this does is this powers the motor upstairs, and it makes, you know, the third leg, okay? And the third leg is basically, it's not the third phase. It's the third leg is a phase additionally between the original that one, and the third leg is a phase, and that one and the third leg is the second phase, and the first phase, of course, is between these two. That's delta. So that's how that works. So these two breakers, they only power each individually a rotary phase converter in the attic. So if you follow these lower breakers, they go down in these wires, and I got them identified as you know, as to which leg they are. They come down in this conduit, forgive the flashlight, and I've got two, you know, there's my 120 volt outlets, and you can see there, that's my twist lock, okay? And here I unplugged it. So that's a, I believe it's a L1530, okay? And what that is, I got a ground, and then I got like leg 1, leg 2, and leg 3. So the third leg is that coming from the rotary phase converter. You know, ground is ground. Leg 1 and leg 2, okay, is 230 volts. So leg 1 and leg 2 are the same as the legs coming in on the main breaker. Leg 1 and leg 2. Okay? Leg 1 and leg 2. Now leg 3 is the generated leg, which again is those 2 phases. So that's the deal. So right now this cord is running my air compressor. That's an old Sears air compressor. That's 230 volts single phase. So that's where this cord on the floor, that's where this goes. So I'm only basically using the ground, leg 1 and leg 2, which is 230 volts. Leg 3, I'm not using for the compressor because it's just a single phase motor on my air compressor, and that's a temporary air compressor. I got a bigger one upstairs, doesn't matter. So that's how that works. So the all-important third leg is what gets generated upstairs, okay? And so you know that's how that works. So at all times I've got single phase with the 2 legs here from these 2 breakers. Now coming down from these 2 conduit runs is the third, you know, powers up, single phase, and the third leg comes down. And where does that go? Well, blue is the identifier tape for the third leg. So I got blue, blue, and this one's blue, trust me. So coming down here, kind of kneel down, it comes into this little mini fuse box with only 2 breakers. It's like a little small fuse box, and I think they use these for like you can use them for anything, of course, but like hot tub panels, you know, a hot tub installation, whatever. So these 2 breakers here, again, one is rotary phase converter output number 1, and one is the second rotary phase converter output, and they come in the top there, and you know, that protects the third generated, you know, the generated leg of each converter. So it makes it easy, again, you know, that breaker's for, you know, that one, and that one's for the second breaker. So on the bottom of these circuit breakers, the output is joined together, and it comes down here around, and they both come into this terminal on that little bus, okay? So each rotary phase converter, the power feeding them, that's the power feed RPC1 and RPC2, and the power output via that third leg comes into here, and each goes through its own circuit breaker, which the outputs are tied together, and they come to that distribution bar. Now that bar, it used to be a ground bar, but you can take out the ground jumper to the chassis, to the box enclosure. So so that's now the third leg, and you can see these 2 wires over here. Each one of those is a circuit. So one of those goes back up, around, and goes down here, and you know, feeds my receptacle. So basically, the output of these circuit breakers, which is the generated leg, you know, is one of those terminals, which is, like I showed you before, that third leg right there. So that's between all 3 of these legs, 1, 2, 3, between them are the phases, okay? So it's a little different because right now I've got single phase between 2 of those legs, and if I turn on the rotary phase converter, one or both, they both make the third leg. Then I can have 3 phase there. So with the rotary phase converter off, you know, it's just single phase 230 volts, and when I engage either one or both of those, it generates the third leg, and I have true 3 phase here. Okay, So that's how that works. And you know, I just wanted to, I got these covers off just to show you, you know, how it all works. It's a little different system. So I have active single phase 230 volts in all my outlets, and you know, around the shop I've got outlets. You can see, you know, on the back wall I've got outlets. I've got over everywhere. I've got, I think it's every 6 foot. So my welder is plugged in there. My TIG welder is plugged in, and that's single phase. Yeah, it's dark in that corner, so that's single phase. But so this side of the shop, I'll kind of show you. It goes up in the ceiling because of the door. It goes up in the ceiling and goes around and comes down in the top of the breaker panel. That's what the deal is. That's how it gets to the other side of the shop. You know, obviously it doesn't matter. Your wiring is going to be different. So the output there is the left side of the shop and the right side of the shop. That's what those are. And I've got another 1, 2 outputs, and then I can use the top two, the top as well, I should say. So I got basically 2 or 3 outputs here more. Whatever, I can stick as many out there. It's just handy. So that's that. Let me take you upstairs and show you the you know, what's on the other end of these switches, and give you a better idea of how this works. Alright guys, I'm up in the attic here in Doozer shop, and you can clearly see here I got 2 phase converter panels. I just had the one over on this side, and I added this one on the right side. So you'll see in the floor, those are the conduit runs that come up from the circuit breaker panel below. Right? Now let me kneel down here and I'll show you. So I drill these through the floor, and I try to be nice and neat. You can kind of see here. So basically the whole pattern in the floor is exactly the same as looking at the top of the breaker box. These pipes, these conduit pipes are straight down into this top of my breaker panel, which makes it nice, you know. So what I did is I got these sitting on a 2x6, and the wires kind of come in the back. You can kind of see. You sit down. Yep, they come up through the bottom. So that's my my one motor, and of course that's the other one. Now these motors, any 3-phase motor can be used as a rotary phase converter. These motors are 6 horsepower. This is Leeson motor. But the deal is, I got these motors cheap because they're rated at 5 horse and 50 hertz. Okay, 50 hertz is kind of like a European frequency, and the voltage on them is like 380/415. But you know, that's basically 5/6. 5/6. Yeah, that's a lot of syllables there. Of 60 hertz. So if you add another 1/6, 50 hertz becomes 60 hertz. and 5 horse becomes 6 horse. So if you up the frequency, you up the current draw, you up the RPMs, and you up the horsepower. So long story short, these are actually 6 horsepower motors. They're rated at 5 horse at 50 hertz, but they're going to be 6 horse at 60 hertz. And it's not too complicated, but if you get looking into motors and stuff, that's how that works. Now, you'll notice I got rubber isolator feet on these, which is kind of cool. These are 1200 RPM motors at 60 cycle, 60 hertz. I think they're like 1000 RPM at 50 hertz or something. Whatever. But the point is, these are 1200 RPM motors. They're huge. These things are 230 pounds a piece. Okay? They're just big motors. And you can see I got them sitting very close to the wall. So the weight of the second floor, it's you know, up here in the attic, it's right close to the wall. So that's okay. That's all good. But one thing, they make a great rotary phase converter generator, because they're so big and they spin at the slower RPM. They're nice and quiet. But the thing that makes these really nice is they're delta wound. And you're going to say, Doozer, what's the difference between delta wound and Y wound motors? Well, delta shares the phases. Let me make sure I say this properly. Single phase comes in and 2 phases are generated. Okay? That third leg that comes out, that third wire, is actually 2 phases. It's a phase between L1 and L3. Let's call the generated leg 3. It's a phase between L1 and L3 and L2 and L3. And that caution symbol, I mean, that's a delta. That's basically what this is. So if you got you know L1, L2, and L3, okay, look at the triangle, that L3 is the generated leg. So it's the third leg, but it's not the third phase. It's actually 2 phases. It's creating a phase between L1 and L3 and L2 and L3. So that's kind of what the deal is with a delta. You can have a Y connection, which I don't have a, just picture it's like a letter Y, but you're going through 2 coils per phase because there's a center point that's not connected. Magnetically, when everything's spinning, I have come to observe that delta seems to share the first initial input phase. It shares that with the second and third phases. Even if it wasn't spinning, it's going to share it to some degree, right? In a Y configuration, pretend if it wasn't spinning, it really doesn't share it because of that center point. I'm probably not describing this very well. I'm a mechanical engineer, not an electrical engineer, but I know quite a bit about 3-phase and stuff, but maybe I'm not explaining it well. But anyways, this thing doesn't hum, it doesn't buzz. The proof in the pudding is in the eating of the pudding, and the results are that this motor, let me just say this. I've made phase converters, rotary phase converters, out of Y-wound motors, and they're horrible. They buzz, they hum, they're loud, they drone. These delta motors, folks, are awesome. Let me just talk about North America phase converter. North American? I guess it's North America. I found these guys on eBay, of all places. And this is the first panel I bought. That's the second panel. The deal is, I think they have these panels for $275. You get the 3 start capacitors on top, and the capacitors below, the silver ones, are the balance capacitors. So you always want to balance your converter. You don't have to, but that's another reason they run quiet, is not just the start capacitors, but when they're running, the balance capacitors underneath there to balance the third leg against the first leg and the second leg. That helps make a more uniform sine wave on the generated leg. These are kind of nice. There's a terminal block for input single phase here, and you get the motor connection and the third leg there. This is a contactor. The white one's a contactor. The black one is the contactor for the start capacitors. That little box with the little, those are the wires from the push button, that little black box there, that's a current sensing relay. Supco used to make them, SUPCO, Supco. I don't think that's a Supco, that's some other brand, and I don't know the name. It's something like Tektronix or something. It's not Tektronix. I don't know what the name is. But anyways, really awesome starting relays. And you can buy individual components from North American phase converter. But you know, $275. I thought that was a good price because you get this beautiful metal cabinet. And granted, you know, you can buy these capacitors for like $10 a piece. You know, if you're building your own, so it's 10, 20, 30, 40, 50, 60 $60 in capacitors. You know, and you price out the components. You know, that's a really heavy duty starter relay. That's probably $50. You know, maybe these terminal strips, I bet you that's, you know, $15 right there. I bet you that's 20, $25 for that one. You know, another relay, that's probably $25, $30. That's probably $25, $30 for that. So, you know, you can piece this stuff together, but you know, you can for $275, the little bit extra money. I mean, the enclosure itself is $50. You know, I look on the internet forums, the machinist forums, and people don't. They'll go out of their way to try and save money, and they're just spending more money, nickel and diming themselves to death. So I have no affiliation with this company, North America Phase Converter, none at all. But I just think for the money, this is a really good price. That's why I ordered it, and my time is worth something. Putting this together, I could do it, but you know, they give you a nice bracket for the capacitors, and everything's all like, you know, made up, done and done. Not a commercial for them. So I see, what's that one? They're giving away rotary converters to all the YouTubers. American Rotary. American Rotary. I've seen American Rotary. Well, I've heard them running on YouTube, and boy, their motors, I suspect, I don't know, but I suspect they're Y-wound, because it's really hard to find. It's rather uncommon to find a Delta 230 volt motor. You can wire them for 480 in a Delta configuration, but this happens to be not a 9-wire motor, but a 12-wire motor. they bring more wires out of the windings into the pecker box there, and you can configure it for delta at 230 volts. That's the key. I suspect American Rotary are Y-wound because I've seen a lot of the YouTubers have them. They had some giveaway. They're giving away the 20 horse converters, and that's awesome. I wish I was given an American Rotary converter, but I was not. I guess I'm not. I'm not even 1,000 subscribers yet. I'm a small potato in a large field, but nothing against American Rotary. But I think their converters are quite loud, and they put them in soundproof enclosures. They make them. You can mount them outside. They offer the weatherproof ones. So this is not American Rotary. This is North America. I guess they're capitalizing on the same name or similar name rather. I don't know. I have no clue. But I'm kind of talking these guys up a little bit because I just think they offer a good converter panel at a good price. I had a problem. I had one of these capacitors leak. There's that capacitor. And I called them up to order a new one, and they said, well, we'll just send you a new one for free. I'm like, okay, thank you. And I had another one. I was changing wires or something, and I noticed the screw terminals on a couple of these were stripped out. They're tightened so tight, and they're like a metric screw, like an M3. Maybe they're M4. I don't remember, but they're stripped out. And I called them up and I said, hey man, this thing's not that old, and some of your screws are stripped out. So they sent me a new one of those for free. So pretty cool bunch of guys over there, guys and gals. I tried saving that one. I think I tapped these out for either 632 or 832, I forget which, and I put all new screws in. I don't think these, they don't have the little washers like the originals do. But like I say, I wanted, even though they're nice enough to send me a new one, I wanted to have a spare in case, you know. Alright, so that's cool. Where was I? Oh yeah. So, this is that irrigation wire from my push button. That controls the starting and stopping. And I ran it in the same conduit. I went with, I come out of the floor with the EMT, and then I go to the flex conduit for the input, and then the flex to the motor, of course. And that's the second one. It converts from EMT to the flex conduit, and then it goes again to the motor. So you got the power input there, and then these are the three phases for the motor, and here's that third leg that goes back down. Where does it go? Yeah, it goes back down. So that's how it is. I got two legs coming in. You can see in the back the third leg going out. What you're supposed to do is run this to your three-phase machine or run this to a three-phase panel. But I didn't want two panels. I did not want two panels. As long as I'm protecting the output with a breaker, which I am, that's going to work. So these are essentially the same. They're basically the same darn thing, wired up exactly the same. The only thing I wanted to show you guys up here is this, okay? Now, it's probably bad. No, I can bend these wires. So as I said, that's the motor starter. It's a contactor for the motor, and that's the capacitor relay. That's the relay that cuts in the starting caps. Okay. You can see the that white wire. Okay. This white wire used to come off of this current sensing relay. Okay. So this wire, and you can see I left the jumper in the bottom here, used to plug on. What I did is, instead of having the output of that current sensing relay, which controls the starting circuit, which is essentially that contactor there, which brings in the start capacitors. If I break that circuit, then when the main power relay comes on to energize the motor, it energizes the motor without bringing in the start caps, right? So the current sensing relay controls the start caps. This relay is a high current relay that brings the start caps into the circuit. But if the opposite converter is running, I don't want to bring the start caps in to the circuit when I'm already generating three-phase. So instead of having this wire plugged in, connecting, you know, the output of the current sensing relay to activate the capacitor start relay, what I do is I switch that with these white wires, and the white wires go over here, and you can kind of see they're going to the auxiliary contact of this main contactor that starts the motor. So if that motor, rotary phase converter, generator motor, whatever you want to call it, if this is running and this contactor is pulled in and I'm generating three-phase, that's a normally closed auxiliary contact switch. So that breaks the circuit. So if this one is energized second, the connection's broken and it won't energize the start caps when this one's energized. So if this motor is generating three-phase, this will be on, and it'll break the contact between these two to inhibit the function of the capacitors starting, because I already have current flowing, three-phase current. The same is true with this. If this is the first phase converter to be started, and I may want to start the second one, these white wires, it breaks the circuit. So if this starts up and this is running and this is generating three-phase, it breaks the circuit on these wires over here. Alright, now let me hunch, my knees hurt. Oh, over to this one. You can see the same thing. There's the second current sensing relay, and there's the white wire, and there's the other white wire. Another, again, jumper. That terminal used to connect directly to that terminal. There you go. Maybe. Alright. So that wire used to jump right over to here, but now I brought a longer set of white wires. They go down into this crossover, and they come out here, and like I said, that contactor, if that's turned on and I'm generating 3-phase on this panel, then the capacitor bank for starting is inhibited. It's funny, these three are in that L shape and these are straight across the top. It's the same thing. I don't know why they changed the arrangement. So that's how that works. That's the key to success here, is those white wires. They come in, and this starting circuit is inhibited by this relay if it's energized, and this capacitor starting circuit, if this is running, is inhibited by the relay there. So let me sit on my little stool here again and I'll show you. Alright, so this is that spare starter contactor. So this is the coil, the input for the coil voltage, 232 volts there. And it's got 4 terminals that go straight through, right? And those are normally open. And when the coil pulls in, then they close. So that energizes the motor. What they do, you might be able to see, they double up. They got red, red, and black, black. It's just for extra current capability. Instead of using one terminal going through, they use, you know, 2 next to each other in parallel. So it gives them a little more ampacity through here. And seeing as this is, you know, switching a single phase load, basically you're switching 2 wires, and if you got 4 terminals, that's what they're doing, is they're just pairing them up to allow this to carry more amperage. Okay, no problem. So coil in, here's your single phase contactor, high current load to start that big old motor. And this on the side, like I said, is the auxiliary contact. Okay, right? So what the deal is, you can kind of see why they call it auxiliary. It's white and it's tacked on the side. So there's 4 terminals here. The lower ones are normally open. Okay? The top 2, where I hooked the white wires, the very top are normally closed. So the circuit's made when this is off, and when this is energized on the top 2 terminals, it breaks it. That's what's doing the inhibiting. So the normally closed, the normally open contacts on the bottom, that's the hold in, right? So the hold in, when you push the start button, it energizes this coil and puts power to those coil terminals. And once this is pulled in and energized, the bottom 2 auxiliary contacts, they hold the coil in, right? So this thing is held in the energized position by the bottom 2 auxiliary switch contacts. And kind of see on there you go, little diagram of what it is. You can kind of see there, it says right there, auxiliary contact way at the bottom, normally open, normally closed. Easy peasy. So these are being used at the bottom, factory pre-wired for the hold-in function. And when you hit the red button, it breaks the circuit and this drops out. But these top normally closed auxiliary terminals were not used at all, right? They weren't used at all. Kind of show you. That's where the white wires I got. You can kind of see in the background there's a black wire, and I'm using the front ones. I'm using on that one, and then the very same, I'm using them there. So that works. I said, I'm sorry that was a long drawn out explanation, but let me kind of back up. that's as complicated as it is, folks. It's not very complicated. Basically, I'm using that relay's auxiliary contacts to inhibit the starting capacitors on this one. And on this relay, I'm using the auxiliary terminals to inhibit the start capacitors on this one. Because like I say, when one starts, you're making three-phase. You just want this one to come in line, or come online. You don't need to start the start capacitors to give a kick for that motor, because this one's already generating three-phase. So that's it. I'm pretty happy with all this. And you know what I did? I put it on this 2x6. You can kind of see. No, maybe you can't. I put on the 2x6 here so I could still kind of see there, have access to slipping in pieces of conduit. Doesn't matter. But that's it. That's I can either run one or both. Let me give you Alright guys, what I'm going to do here is I got the camera situated. I'm going to show you guys what it sounds like. You know, I've been bragging about how smooth and how quiet these all are. Hopefully the microphone on the camera can pick up how loud these are. And they're really pretty good. So let me click this starter contactor on. And I'm going to click on one, and then I'm going to click on the second one. So here we go. Okay, that one's running. Let me click on the second one. You can hear both of them running. And there you have it. That one's running now. Most you hear is the fans, because they're totally enclosed fan-cooled motors. I love it. I think these are the smoothest running motors. In the configuration I have, you only use as much phase converter as you need. Most of the shop I can run on just a 6-horse converter. If I'm running the big planer or doing some heavy hogging on the big lathe, I'll bring in the second one. But you know, that's it. I just thought I'd show you guys how I wired it all up and showed you, my circuit. Hope you enjoy, the little bit I showed you here. If you got any questions about phase converters, I know what works for me. Like I said, it's a little unconventional, because they want you to power a dedicated machine, or they want you to power a second breaker panel, be it a 3-phase breaker panel. That's a lot of breakers, a lot of space. One thing I wanted to mention, I on purpose tried to overload my one single phase converter. What I did is I tried starting my lathe. Like I said, it's a 2-speed lathe. Low is 4 horsepower, which it starts fine because it's a 6-horse converter. And high is 8 horsepower. So if you start the motor on the lathe in high speed, which is 8 horsepower, it'll start unloaded, but you have it in gear, it won't start it. What it does is it lugs down the motor in the lathe. It kind of just tries to spin it up, and it'll pop the breaker not on the third leg, not in that little panel. It'll pop the main breaker, which is a 20 amp breaker that feeds the rotary converter. Because it just pulls so much on that third generated leg, it actually will blow the breaker feeding the rotary converter. So what I did is that third leg, instead of running two 20 amp breakers in that little panel, I downgraded to 15 amp breakers. And I might try the test again to see if it blows that generated leg breaker first. But everything's protected, and I have single phase 230 volts everywhere in my shop, and with the push of a button or two buttons, I have 3-phase everywhere in my shop, the same outlets. So like I said, the single phase is always energized, and with the push of the button I get the third leg for true 3-phase. So kind of different. I thought about drawing on the whiteboard if you guys didn't understand what I was describing. Let me know if you need me to do a follow-up video, and maybe I'll draw it on the whiteboard. But for now, I'm up in the attic here showing off my new toy. This is Doozer Shop.